Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So near the beginning of this series, I said that classes were a container of related methods. And we saw how the console class contained methods related to working with the console window. We talked about how you access a method by using its class name and the period, or rather the member access operator, to access the methods in that class. We also looked at creating simple helper methods. At that time, I was emphatic that about where the method definition should be positioned inside of your code. The method needed to be contained within the correct code block, the class code block, in order to work properly. Now, truth be told, I intentionally oversimplified my explanation about classes and helper methods and all of that stuff because I knew that we'd want to talk about it, give it its full treatment in this lesson. I've also found that object-oriented programming and classes are kind of the entry to that thought process, is one of the most challenging things that a new developer will encounter first. There will be other challenges along the road, but this will be one of the most challenging concepts. To get it right will unlock a lot of ideas for you in answering the question, why did they do what they did with the .NET Framework? How do I properly create my applications, and so on? How do I delegate responsibilities to the right classes, and so on? All right, so as you'll come to learn, virtually everything in C# and the .NET Framework is a class, or it's part of a class. That's really the purpose of this lesson. Not so that you can create your own classes necessarily, although that will be required at some point as we move through these lessons. The intent here is to use the classes that were built by Microsoft and that are available through the .NET Framework class library. Now, the truth of the matter is that I couldn't possibly cover everything that there is to cover about object-oriented programming classes because it's a vast topic. If you really want to learn about the power of classes, then you'll want to learn specifically about object-oriented programming. But that's a topic for another day. I just want to present enough for you to get you comfortable with the basics of how to use the existing .NET Framework class library classes, as well as how to create super simple classes of your own. All right, so using the techniques that we have used up to this point, let's go ahead and create a new project called Simple Classes. Make sure it is a C# console window application. All right, and we'll begin by creating a class of our own. Suppose that I want to create an application that works with cars. I might have a car lot and I need to keep an inventory of all the cars that are there for sale. Okay, so to keep all the related information about a single car in one container, I might want to create a car class. So what we want to do is position the caret before the final curly brace right here, somewhere between this curly brace, the final one, and the second to last one that defines the class program. And I'm going to make some space for myself between lines 16 and 20. And I'm going to type the following. All right. So first of all, the keyword class tells the compiler what type of code block we're attempting to create. We're going to give this code block, this class code block, a name. We'll call it the car class, all right? And we'll see how that's used in a later step. What we define between the curly braces in our new car class will be the members of this class, including properties and methods. Classes can contain other kinds of members too, but properties and methods are the most popular, and they'll help us create just a simple class to start off with. And so in this lesson, we're going to create 4 properties. We're going to create a property called make, model, year, and color. And then later we'll create a method. So a property defines an attribute of a class. We can set their attributes in code or retrieve their attributes in code like we're going to do in just a moment. But we set and we get properties, or the values of properties that we define in our car class. So that's a property. A method defines a name body of code that typically represents something that the class can do. So we created helper methods in some of the previous lessons to do something meaningful, like perform some super secret formula calculation that wasn't all that super secret, okay, but we could pretend. So let's begin by creating some simple properties here. And there are several ways to do this, several ways to define a property. However, I'm going to show you the easiest way to do it. The technique combines a shortcut in the Visual Studio IDE called a code snippet, and with a shortcut in the C# programming language called auto-implemented properties. All right. So what we want to do is make sure our caret of our mouse is positioned between the opening and closing curly brace of our car class, and then what I want to do is type the word prop. You can see it finds it in IntelliSense, and then I'm going to hit tab on my keyboard. So I hit the tab key twice. And when I do that, you can see that this sequence, the prop tab sequence, fires off a macro, I guess you could call it in Visual Studio, called code snippet, and it creates that line of code that you see on screen. So notice that the word int is highlighted in a bluish green color. This indicates that you can currently replace that part of the code snippet with your own code. So with the int keyword highlighted in the bluish gray color, I'm going to start typing the word string because I want to replace the data type. All right. And now once I've typed in the word string, I'm going to hit the tab key on my keyboard twice again, and you'll see that the blue-green highlight will move to the my property portion of the code. This is what we want to call the new property. I don't want to use the word my property, too generic. We want to use the word make, like the make of a car, as opposed to its model, its color, and so on. All right. So you can use the tab key now to tab back and forth between these two replaceable parts. Pretty cool. Between the data type and the property name. So once you finish editing the code snippet, then you can press the enter key twice on your keyboard. Enter puts you to the end of the line of code, and then enter again puts you on the next line. Awesome. All right, so let's use this code snippet plus auto-implemented property technique in the previous step to create property definitions for model, year, and color, like so. Prop, tab, string, tab, model, enter, prop, tab, int, so I'll just leave that alone, tab, year, enter, prop, tab, string, tab, color, enter. Awesome. All right, so since this application that we're building will keep an inventory of all the cars on our car lot, as the developer, I'm going to need to collect some basic information about each new car. Now, to make this a real application, I might need to create a graphical user interface, maybe like a Windows Forms application or a Windows Presentation Foundation application type from the project templates available in Visual Studio, or I could create a web page that would help me collect data from an ASP.NET web form, and so on. But for now, we're going to keep this really simple, and we're just going to use our static void main to create a new instance of this class and to fill in the details about each new car that we need on our car lot. So that process, to begin that process in our program, I'm going to want to create a new instance of this class for each car on my car lot. And so you create a new instance of a class using the keyword new, like so. Let's go here in our static void main between the opening and closing curly braces, and we're going to go car. And notice that it recognized the word car now in IntelliSense. Car, my new car equals new car. All right. So an instance of a class is known as an object. So my new car is now an object. Again, an object is not a class, and a class is not an object, although you'll sometimes hear people confuse those two terms. I even do it accidentally on occasion. The class is the blueprint. An object is instantiated or created from the blueprint or the pattern. And then we can manipulate the object in the computer's memory. So in the real world, you can use the same blueprint to create many new houses, right? They call them cookie cutter houses, all right? You could use the same pattern to create the same clothing over and over. Or you could use a recipe to create the same cake or casserole and get the same results each time. So each time you want to build a new house, it'll be at a new address. Each time you follow the pattern, you'll create a new instance of clothing that can be sold to a different customer. Each time you follow the recipe, a new instance of the recipe can be offered during the same meal or a different meal. The same is true with classes. Each time you create a new instance of the class, you have a new object that's distinct and separate from the other instances of that class. All right? It lives by itself. So a class is like a cookie cutter. You can't eat the cookie cutter. You can eat the cookies that you made in the shape of the cookie cutter. So when you instantiate a class, you create a cookie or the instance based on the shape of the cookie cutter or the class, okay? So think of the new keyword that you see here as the factory. It uses the blueprint or the pattern or the recipe or the cookie cutter in order to create a new instance of that blueprint or pattern or recipe or cookie cutter, or rather a new instance of the class. It brings the class to life in the computer's memory and it makes it usable by your application. So you can create many instances of the class, or you can create many objects all based on the same class, but each one is distinct from the others. So what I want to do is I'm going to set the properties of this new instance of car called MyNewCar to their appropriate values. So in this case, I'm going to merely hard code the values here in my static void main. But in a real application, I could present a graphical user interface to the user, and I would ask them, like a web page or a Windows form, whatever the case might be, to collect this information and then create a new instance of this object, and then work with it somehow, do something meaningful with it, okay? So as I type out this example, I want you to notice that the dot, the period, the member access operator is the way that you get to the properties of an object. And it actually will even recognize what you built here in your class. It'll open up IntelliSense to show you the members of the class that are currently available. All right, so here we go. We're going to set the properties of MyNewCar. Notice IntelliSense sees all. Okay, so let's take a moment to dissect this code and really understand what's going on here. First of all, I use the name of the instance of the car class, MyNewCar, to access each of the properties of the car class that I'm going to set. Notice I'm setting it by using the equal operator. I'm setting the property make to the value Oldsmobile, for example. So I use the equal sign as the assignment operator. I'm assigning a new value to each of the properties. These new values for each property are maintained in memory for this instance of the car class, and as long as I have a reference to this instance of the car class, I can retrieve those values back out, or I can change them again. This is called get and set. As long as I'm using it, it stays in memory. When I stop using it, it goes away. All right, we'll talk about that more in a little while. Now, once I have a new instance of my car, of the MyCar class, and have set its properties, I can do some useful things with this instance of the car that I've named MyNewCar. For one thing, it's a nice collection of all the related properties or all the related variables that define the car in one container. I can get to every related thing about the car by using the MyNewCar moniker or identifier. All right. So next, what I want to do then is print out certain properties to the console window, like so. And this will show you how to get the values out of the properties for the instance of MyNewCar. Here we go. We'll use that fancy formatting that we've used in the past. All right, and although this is on a second line of code, it's still the same basic executable line of code. All right, just putting it here for readability's sake. That ends that line of code. Now let's read the line. Like so. In lines number 15 through 18, I'm setting the properties. In lines number 20 through 23, I'm getting the properties. Remember that nomenclature, setting versus getting. Okay, that's important as you move forward past this series of lessons and talk about properties, more properly formed properties in the world of object-oriented programming. Okay, so in this example, I've been creating the simplest version of properties, which I called auto-implemented properties. However, there's a longer form which allows me to write code logic that will execute every time one of these set or get operations is performed in your code. So when you write code that handles either the setting of a property or the getting of a property, they are sometimes called setters and getters. Again, that topic is a bit advanced for now, why you'd even want to do such a thing. Just remember that we're creating very, very simple properties for now, and you can learn more later. All right, secondly, whenever I create a custom class, like the car class here, in other words, a class that I created as opposed to a class that's from the .NET Framework Class Library, I've really created a custom data type, just like any other data type that we've been using in our applications, such as the string or int, or actually more like the date time like we used in the previous lesson. Therefore, I can define method input parameters or return values from methods using that new custom data type. All right, so let's do this. I want to demonstrate how that works. We're going to create a new method, a private helper method called determine market value. And I'm going to allow the user to pass in an instance of the car class. And we'll just hard code a value. And then someday I'm going to write some code to go online and look up the car's value and retrieve its value into the car value variable. And then I'm going to return the car value. All right. Okay, so here I created a helper method that allowed me to accept an instance of the car class called car. And I've merely mocked up the functionality as I kind of wrote this little comment here for the sake of brevity. But the key idea here is that you can use your new class as a data type anywhere that you would typically use data types in your code, such as input parameters. All right? Okay, so now you might think that it's strange that I called the input parameter car the same as the name of the type, car. All right, capital C in the type, lowercase c in the actual variable that I could then utilize throughout the body of my helper method. The first, again, this car, as you can see, it's highlighted in that aqua color. That means Visual Studio recognizes it as the data type car, the one that we've defined here. Whereas the second car, the lowercase car, is the input parameter name. And so then I can, reference it down here. If car equals, Buick, then something, all right? So we can use the lowercase c car in order to work with whatever was passed into this helper method. Now, I've cautioned against using the same name for two variables in the past. This is just a common convention. I've also seen people use something like this with an underscore just to make sure it's obvious in everybody's mind that we're working with something that's an input parameter as opposed to the class, the type, car. Okay. So now whenever I want to call this new helper method that I've created, I would pass an instance of the car class like so. So here I would go double market value of car, because I expect a return value, because I expect a double to be passed back, this value 100, which is hard-coded. I expect that to be passed back from calling the helper method. But here I'm going to call determine market value. I'm going to pass in my new car. All right, like so. So that's how you would work with the car data type. You can use it now anywhere in your application where data types are accepted. Great. Let's talk about creating class methods. We've created a helper method, but what if we wanted to create a method on our car class here? So I said that classes are comprised of both properties and methods. And let's create a new version of that determine market value method, this time as a member of the car class. And what I want to do is simply copy the body of the determine market value method into a new method, a member method called determine market value. So I'll go public double determine market value. I'm going to paste in that code I just copied. Okay. I'm just going to change the body of this to be a little bit more meaningful this time around. So let's go ahead and get rid of this. So we'll do if this dot year is greater than 1999, or actually 1990, then car value equals 10,000. Else car value equals 2,000. Okay, so we'll give you money for your trade-in as long as it's newer than 1990. Otherwise, we'll just give you a flat rate of $2,000. Great. Notice here that I use this keyword called this. The this keyword allows you to access all the private and public members for an instance of the class. So when I type the word this and I hit the period on my keyboard, IntelliSense knew that I'm talking about the car class, because that we're dealing with the current instance of the car class, whatever that might be when we create a new instance. And so we want to take all of the values of that instance and make them available inside the body of our method. So I can get to this dot year or this dot model or this dot make, and it will return back, in this case, you know, Oldsmobile or Cutlass Supreme or 1986 or silver, you know, based on whichever property. And so admittedly that this keyword is optional. I could get to the year for this instance of the class without using the this keyword. However, my personal preference is to use the this keyword because it's expressive and it helps you and everybody else know that where the identifier this year came from. I mean, if you have a large body of code, you're going to say, well, what is this year thing? Where did they get that from? Oh, it's part of the car. Oh, I see it. It's up here, car. All right. By using the keyword this, it's obvious to me what, you know, where that came from. It's part of the class definition. All right. Okay. So finally, what I want to do is call this new method, and I want to display the car's value. So let me clean this up here. I'm going to go up here to the top. I'm going to get rid of this, and I'll just do a console.writeLine. I'm going to do it all in one line of code. So cars value, and remember how we formatted a currency value like so. So then we'll call my new car dot determine market value. And there we have it. So I'm using that string formatting code that we learned about from a previous lesson to display the return type, the double that's returned from this, as a dollar amount using that :C formatting code. All right, so now let's go ahead and run the application. Now, what will my car be worth? It'll be worth only $2,000 because it was before 1990. Awesome. All right. So in this lesson, we used a very concrete example, the example of a car. A car is easy to conceptualize and represent in a class because it's tangible and there's a real-world equivalent. As you begin to build applications, especially in this series of lessons, you will not be responsible for creating your own custom classes. For now, I think your main exposure to classes will be those classes that are created by Microsoft in the .NET Framework class library. In most of those cases, the kind of classes that have been defined in the .NET Framework class library do not have real-world equivalents. In other words, they're more conceptual in nature. For example, I might work with a class that represents the connection to the internet or a stream of data, which is sort of like a pipeline of data flowing from one place to the other, or a span of time like we saw in the previous lesson. In these cases, we're not working with something tangible that we can touch and feel, but rather we're working with something that's conceptual in nature. So as you mature as a software developer, you might want to invest more time in learning how to create your own library of classes that interact with each other as a means of breaking down real-world problems that are conceptual in nature into code. This process is called object-oriented analysis and design. Again, that's not something that we're going to cover in this series of lessons, but you can learn more about on either Channel 9 or Microsoft Virtual Academy or on my own website, www.learnvisualstudio.net, where I spend a lot of time talking about these things. All right, so to recap, a class is a data type in .NET that's similar to those basic data types that you've been using up to this point, like string and int, and datetime, and so on. You can define a custom class with properties and methods, and then create instances of the class, or rather create an instance, create an object using the new operator. Then you can access that object's properties and methods using the dot operator, the member access operator. So there's still quite a bit to say about classes. Don't worry if you don't understand everything about classes, why you even need them. Just make sure you understand the process we went through to create a new class, how we created properties using that prop tab technique, how we created a method that allowed us to pass in the type car, right? And then we created a method that was part of the class itself that we could call on our instance of the car, like we did for this example right here, and how we were able to get results and print them to screen. If you just understand that much, then you're doing all the right things. We'll fill in more details in the coming lessons. You're doing great. Hang in there. We'll see you in the next lesson. Thank you.